for the talks that are coming up this morning. What's that all about? Well, the Excalibur program is this great big complex beast. A little bit of it, about 10% of it, is this testbed program. So hardware and enabling software is about trying new stuff out, and particularly about giving people access to novel platforms, novel technologies that they might otherwise either not have access to or have quite constrained access to. So conventionally, you might say, okay, I would like to use a particular system, a particular service. You apply for access to it, and then what you can do with it is quite limited because it's a service. And what we're trying to do with hardware and enabling software is to say, okay, actually, these are test beds, they're small scale, they're reconfigurable. If you applied for access to one of the test beds, you could say, okay, can I have the whole thing for a couple of weeks? Can I reconfigure it? I have some ideas of how I would want to use it, which are just not possible on a production service system. We just want to try a new scheduler. Okay, we need to have a chat about that. So a key part of this is not doing it in isolation. And we heard from Mark earlier on about the importance of having industry engagement as well as community engagement. So it's been really, really gratifying to see how technology partners that we've been working with have been really eager to give the community access to pre-production in some cases, but kind of leading edge technologies, products and services that are just coming to market. And I'll rattle through, I'm not going to go through the projects in detail here because we don't have the time, but there's some slides that have some information about the projects that the program has supported. So what's relevant to people who are here with an interest in AI? Well, we have things like the Cerebras wafer scale engine in Edinburgh. We have the GraphCore IPU testbed at UCL, but actually quite a few of the systems that we've put in here have a kind of AI relevance. So, for example, a lot of people are interested in running their codes on different GPUs, not just NVIDIA GPUs, but maybe we'll try some AMD GPUs. And again, this question of, okay, can I just have access to this system? Can I reconfigure it? Can I just grab it for myself for a bit? With these test beds, this is a reality, this is practical, and this is the thing that you can do. So here's some test bed projects that have, well, the ones on the previous slide have finished, but the systems are still available, so you can still tap into them. Here's some that are on the go at the moment, and you can see an example here, which I think is quite an interesting one, of RISC-V. So RISC-V machines, a lot of people are getting very interested in. Those systems often have a neural engine because it's just sort of comes with the territory now. So it might not be a GPU, it might be a dedicated AI engine. And these things that, as a researcher, they're available to the Excalibur community first and foremost. This is really done to service the Excalibur community, but we want to make them accessible to the wider science community as well, just that Excalibur projects have first dibs on these systems. And these are the latest batch of projects that are just upcoming. There's one that's not on there, but we're just supported to put up a Ponte Vecchio testbed, the Intel GPU. And what we're starting to see now, in quantum computing, of course, it's quite nice to think that actually to maybe just take a little bit of a step into quantum computing too. But what we're starting to see now is people saying, okay, I've had a look at the technology, I've had a look at these different systems, products, services, and now maybe I can use them in interesting and new ways. And I think this particular project to look at PETSI on the wafer scale engine is an especially interesting one, because what we're saying here is the wafer scale engine is a machine for doing AI algorithms. It's an AI machine first and foremost, but much as when people first started to look at using GPUs for doing AI, now what the team at Edinburgh are doing is saying, okay, well, this thing was conceived as an AI engine, but well, perhaps we could just use it to accelerate certain parts of the Betsy code base. And, it doesn't actually matter that it was conceived as an AI engine. It offers quite useful underlying primitives that we can tap into to do useful science. So I rabbited on a little bit about the projects, but I hope that was interesting and useful. The details, I'll put a link in at the end, but the details are on the Excalibur website. There's a nice projects page. And a couple of slides on what went well and spoilers, what didn't go so well. So what went well? Well, things like that wafer scale engine, that was actually the first deployment of one of those systems in Europe. So it's quite nice to think, wow, we've got some firsts here. And the work that Paul and colleagues have done on I/O and performance characterization, again, this is world-leading work. This is the UK right up there at the head of the pack. So this is very nice to see. Work on benchmarking. I appreciate this group has a particular focus on AI benchmarking, but there's been an H&ES project which is pulling together benchmarks from across the community, trying to cover a wide range of use cases. And the result of that is a reusable exascale class benchmarking suite that there's been a lot of interest in internationally. So again, the idea that we do something here, we do something in a group like this that has potentially has global relevance. This is really exciting. We've contributed code upstream, so software packages like Parafew and GR-Chombo actually pushing code back up so that it's in the mainstream code base that everybody is pulling down and using. This is not a little standalone activity which fizzles out at the end of the project. It has a kind of life, a digital epitaph, which is much longer than the project itself. We talked about novel architectures. So it's worth keeping in mind that some of these things you won't find anywhere else at all anyway, at the moment, at least in this country. And some of them are in quite short supply. So we want to make sure that people who have an interest in any of those technologies I showed on the previous slides from the projects, we want to make sure you know they're out there and you know where to go, who to talk to get access to them. Some of these test beds actually became part of regular service provision. We didn't particularly seek to do that, and it's not necessarily a goal going forward, but sometimes there is a sort of serendipity, and that happened with the Rockport Networks Interconnect, which is now a significant part of the Dirac system in Durham. So it's very interesting to see. I don't expect to see this as a matter of course, and it kind of flies slightly in the face of reconfigurability and experimentability. We want to be able to take things down. We want to be able to radically change the configuration. So that's probably a little bit of an outlier. And we talked about RISC-V. I think the real lesson for me has been these 2 points at the bottom. So technology partner, vendor engagement. It's been absolutely brilliant to see how many companies want to get on board with this, want to be a part of it. And I've got to take my hat off to you for doing that. We really appreciate it. And this group of projects has regular monthly meetings to exchange information. And again, this has been hugely useful. We've been doing that all online, and we're just starting now to think about, okay, perhaps it's feasible to start meeting up in person again. So this is actually, I used to do this all the time, this kind of thing, but this is the first time in about 3 years that I've stood up in a room like this full of people and given a talk like this. But maybe the time is right to start doing this a bit more. What didn't go well? Okay, well, there were just a few things going on in the last couple of years. There's this thing, this coronavirus thing, which has been a bit of a nuisance, global supply chain disruptions. And of course, there's a regular kind of ebb and flow of products and technologies and ideas that sometimes work out, sometimes come to market, and sometimes get cancelled or radically remixed. So For example, we saw that with Gen Z, the Gen Z interconnect, which is subsequently absorbed into something called CXL. So we planned to do a load of work on Gen Z, and now we have a CXL project coming up. That's just on the starting grid. And one of the important things for H&ES was to understand that it's okay to fail. It's okay to not succeed. It's okay if a project doesn't deliver what we thought it would in the first place. I would say, provided we can learn something from it. If we just throw our hands up and say, okay, never mind, next, then we've not necessarily learned from that experience. So we want to make sure we learn from failures, and we also want to try and understand if the sort of sands are shifting under us. And why is all this important? Well, it's important because we're just starting to talk about what a possible follow-on to Excalibur could look like. And as part of that, what could a testbed type program like this look like? So any ideas and input from people in a group like this, online or in the room today, are very much appreciated. We did notice that some people who applied to the program, in spite of often having quite a bit of a dialogue with us, weren't really sure what it was about. So this is something that we found sometimes caused a little bit of a problem for people. That they were put together a proposal that was a really great research project, but it wasn't a test bed for novel technology, and it wasn't a project to explore the potential of enhancing some enabling software like Paraview. So that was something that if we carry on with this, if we have a successor to Excalibur, maybe a successor to H&ES, we want to make sure that we communicate better about what we mean by those terms. And in spite of all of that, some people would put in proposals for things that were essentially buy me a cluster and I will go off and do some interesting things with it. But there was no novelty about it. It was essentially, here's a funding opportunity, I'll just put something in. So kudos to them for trying, but unfortunately, it was not going to happen. Something else we noticed was that actually this program inherently favored people who had teams in place who could reassign people and who were not necessarily particularly wedded to the timeline for example, a postgraduate researcher's contract. And what we hope to do if there's a follow-on activity is to be a little bit more flexible about that. H&ES was constrained by being funded as capital, so we would get to financial year boundaries and everything would get extremely awkward and painful as we've been trying to shuffle money around and make sure that it appears in the correct year's budget. This is not great if you're trying to recruit and retain staff who are highly skilled and highly capable and also highly nervous that their contract is not going to be renewed. So hopefully we can learn from that experience. And fundamentally, a lot of that's driven by, as I mentioned before, the capitalization approach. And it may be that there are other ways of approaching funding an initiative like this. So perhaps it's a multi-year grant, which does not then go through normal research council processes. So we're just starting to think about this, and we'd love any feedback and observations that people have. So this is me just about done. I talked about those projects. Most of them, not quite all of them, but most of them have a web page up on the Excalibur site under /projects. So do go to excalibur.ac.uk and have a rummage around. What I would say about this is a great opportunity if you've been doing AI on, let's say, off-the-shelf Intel, NVIDIA hardware, and you're thinking, how portable is it? What if I was going to try and run this on another architecture? What challenges would I encounter? We've got a smorgasbord of different types of architectures and underlying operating systems and schedulers and so on that you can be playing around with. Performance is something that people are becoming extremely interested in. So we're starting to move from, can I do it? will it work to will it work in a way which is useful? And for example, when we look at RISC-V, there's a clear trajectory there to say, can we make RISC-V work in a way which is suitable for deployment in these sort of large-scale systems that people like us are interested in. For the AI use cases specifically, it's important to note that some of those products that we've talked about there, they don't necessarily provide the full coverage for all of the features of something. I don't know, if we said PyTorch, for instance, you wouldn't necessarily find that all of that functionality, all of that capability of that package is available. And it's a very much a moving target, because a lot of these products are made by startups who are trying to build the plane while they're flying it. So what bit do people most need? How can we make sure that that bit works and is as performant as possible? And maybe we'll come back to some of the other bits later. So there is that to keep in mind. And as I said about the PETSI project, the simple fact that we've got nominally AI-focused hardware, which potentially has all kinds of other applications. This is very interesting, and I have a feeling that this will be the beginning of something. We now have this technology in the same way that the GPUs gave us access to a whole bunch of new capabilities. It may well be that the nominally AI-focused hardware actually unlocks a whole bunch of other capabilities that we never knew we needed, and we never thought about what we might be able to do with. And I said before that some of these projects have concluded. Well, in general, this is not universally true, but in general, the test beds will continue to be available for the duration of the Excalibur program. So we're expecting that it'll mostly be available until the end of March 2025. So there's a little bit of an opportunity there to get in, have a poke around, give us feedback on what you found useful and interesting. And hopefully, as I say, that will feed into a future follow-on activity. And do drop us a line. So Excalibur-HES@JISC-Bell-AC UK, that goes to myself, Jeremy Yates, who people will have heard from yesterday, and Simon McIntosh Smith, who Jeremy and Simon are the